In this video, we're going to take a look at how to write reliable socket servers that survive crashes and restarts. So what is the problem with the crashing server? Let's have a look. This is a TCP socket server, listening on port 9000, reading numbers from clients, and reporting the product of the two numbers. It assumes that numbers can be parsed as integers. If parsing fails, it crashes. To test the behavior of the server, we use the following client. This is a TCP socket client. It sends 20 requests to the server with a 10 millisecond delay between them. However, for request with number 5, instead of sending the number 5, it sends the string 5 to cause the server to crash. If we start the server, then the client, this is the output. In the client output, we see that request with number 5 never receives a response from the server, and that subsequent requests fail because the server has crashed and there's no one listening on port 9000. If the server crashes, it can't serve more requests, and that's obviously not good. So how can we improve on this situation? One way is to continuously restart the server whenever it crashes. The script here launches the previous server in a loop. If we start the loop script, then the client, this is the output. In the server output, we see that the server starts again after the crash and starts listening on port 9000. In the client output, we see that request with number 5 fails the same way, but after a few more requests, it starts getting responses again here. Running the server in a loop is an improvement. Instead of dropping all subsequent requests, we only drop a few. But there is this time between the server having crashed and having started again where there's no one listening on port 9000 and we still drop a few connections. So how can we improve on that? The trick is to separate listening on a socket and accepting connections into two different processes. So one process is listening on the socket, and then another process is accepting connections on that socket. That way, if processing fails and the server dies, the socket is still open because it's managed by another process. Here is a program that listens on a socket and then spawns server processes in a loop to accept connections. The first part of this program creates a socket and starts listening. This is what we had in the original server. The second part moves the file descriptor of the socket to file descriptor 0, standard in, to make it available to child processes. The third part calls server accept in a loop. As long as the loop doesn't crash, there will be someone listening on port 9000. The server accept program is similar to the original server, but instead of listening on port 9000, it just accepts connections on a socket which is passed to it as file descriptor 0. Standard in. If we start the listening looping server, then the client, this is the output. Now all requests except the one that causes a crash get a response. We see that request with number 6 takes longer to complete. That is because server accept needs time to start up again by the loop script and call accept on the socket. But the request doesn't fail. The client will not get a connection error. And that is one way to write reliable socket servers that survive crashes and restarts. If you want more details about this approach, check out the blog post that I wrote that is linked in the description below. But that is it for now. I'll see you in 1 week.